In this tutorial, we're going to talk about section 9.5, dilations. And a dilation is a transformation whose pre-image and image are similar. And remember that in order for figures to be similar, the angles have to be congruent and the sides have to be proportional. So let's see a couple different kinds of dilations that we can have. We can have this situation, and bear with me, I know that my drawing isn't perfect, but we are going to assume that these two figures are similar. And if you can see, we go from our pre-image, which is the black figure, to our image, which is the red figure. And if we go from a smaller figure to a larger figure, we call this an enlargement. Okay, so what's the other way of doing this called? So here, if we have the pre-image that's larger than the image, we call this a reduction. All right, let's keep on moving. So then how do I find the scale factor? In other words, how do I know how big did my figure go from small to large or from large to small? Exactly how big did it get? So the way that we're going to do that is by, of course, using some kind of relation. Let's take a look at an example. So here we have two triangles. The pre-image is the red figure, triangle RTX, and the blue triangle is the image. So we're obviously going from something small to something large. So we want to figure out just how much it grew by. And it gave us some information that xt on the red triangle has a length of 4, and that x prime t prime has a length of these combined lengths, which would be 4 plus 8, which is going to be 12. So it's the sum of those two different pieces to give me that whole big piece. So how do I find out just how much it grew by? Well, we're going to set up a ratio. And the way that we do that is we set the image over the pre-image. So in other words, I'm going to set up x prime t prime over xt as a ratio. In other words, the lengths. So here, I just found out that x prime t prime has a length of 12 and xt has a length of 4. So what does this come out to be? And the answer is 3. So the blue figure is 3 times as big as the red figure. So that's how you do that. And just a word of caution as well. Anytime your ratio is bigger than 1, you automatically have an enlargement. And that's true for all of these. Okay, anytime this number over here, this 3, is bigger than 1, it's automatically getting bigger. So that should tell us that if the number is smaller than 1, in other words, like a fraction or a decimal, then it's going to be a reduction. So now, how do I graph a dilation? Let's say I have a triangle in a coordinate plane with these coordinates, like so. So I have triangle EML, E is at 0, 0, M is at 3, 2, L is at 3, negative 1. All right, and I'm going to graph the triangle under a scale factor of 2. So in other words, I'm going to give myself some instructions here. I have all these XY coordinates, and my instructions are going to be, very simply, that whatever XY coordinates I have, I'm going to double them. In other words, I'm going to take my x's and multiply them by 2, and then take my y's and multiply them by 2. So even without having a graph to use with this, I can still find out my new coordinates. So E prime is going to be, let's see, 0 times 2 is 0, and 0 times 2 is 0. So E prime is going to stay right where he is. So let's see about M. Its x-coordinate is 3, so 3 times 2 is 6. And then 2 times 2 is 4. So that's where M prime is going to be. And then L prime is going to be 5 times 2, which is 10, and negative 1 times 2, which is negative 2. And of course, you can plot these points and see the dilated figure for yourself. And that's going to conclude this tutorial.